You can also have interactions that tend to affect not just two species, but a more broad community type of impact. And so we can recognize species referred to as keystone species. These are ones that are not especially prominent in terms of numbers or size. You could measure things either by how many there are or by the total mass there. However, despite not being a huge proportion of the life in an area, they have a big impact. Dominant species are ones that they are very abundant in number of individuals and or in size, and no surprise, those also have very important impacts on the community. Impacts can go in different ways. We can have what's referred to as a bottom-up process, where something low on the food chain tends to impact what's going on all the way up there. Top-down process is when we have something at the top of our food chain or web, whatever we're going with, and effects of that go on down the system. So, for example, a bottom-up process would be, say, we dump too much fertilizer out on the grass on campus, and that excess is washed by rains into Lake Hollifield, and all that extra fertilizer makes lots of algae grow in the lake. And then the lake looks kind of green, slimy, not very nice. And then that has effects on things, say, that would be eating the algae, or too much algae can cause problems as it dies and decays, making things anoxic, stuff like that. That would be coming up from the bottom. A top-down process, one that's been illustrated with fishing here in North Carolina. Overfishing of sharks, sharks being a top predator, leads to more abundance of the medium-sized fish that would otherwise be eaten by the sharks. These medium-sized things include species such as stingrays. So we get more stingrays around. Stingrays have very massive flat teeth, good for crunching hard shells like clams or crabs. So we have more stingrays. They are eating more of the clams. Now the clam fishermen are not happy because there are fewer clams. We've had a pattern go down the food chain from an impact on the top predator on through the system. An example of a keystone species pattern on the west coast of North America, rocky intertidal area. And as an experiment, the most common predator, the relatively large starfish here, was removed from a patch of the rock area. And about half the other 15 species that were present also disappeared. Without the sea stars eating them, the mussels and barnacles were able to take over and crowd out the other species normally present here. For example, these kind of dark ovals are chitons, a type of mollusk crawling around. The green circle there would be a sea anemone. Here's some of the barnacles. So the sea star, by preying on the mussels and barnacles, helped keep those in check and gave more opportunity to other species. Without that keystone species, the diversity of the community went down. We lost some of the things that would otherwise be present. A different sort of keystone species would be Fig trees. Your standard wild figs, as opposed to the ones grown in agriculture for food, require a specific group of tiny wasps as pollinators, fig wasps. And these wasps have short lifespan, so in order to keep their pollinators going, fig trees have to be flowering and fruiting throughout the year if they are reproducing sexually with help of these little wasps. So that means there's fig fruit year-round. If you buy much fresh fruit at the grocery, or if you've ever grown your own fruit, you know fruit typically has seasons, even in tropical areas. And so, fruit-eating animals, of course, when, say, the bananas are ripe, they'll be happily eating bananas. But when nothing else has fruit, there's always the fig tree. So the fig trees provide a critical resource for fruit-eating animals in times when other fruit is not available. And so even though fig trees are not by any means dominant in a tropical rainforest, there are loads and loads of different species of trees there. But the fruit-eating animals really depend on them, and so having a supply of fig trees is very important for the total community diversity. Another example of predators playing a key role, sea otters. One thing that sea otters love to eat is sea urchins, spiny, round, distant relatives of the starfish. Sea urchins, in turn, love to eat algae, including giant kelp. If you have a good population of sea otters eating the urchins, there are not too many urchins, and the kelp can grow, and you get the kelp forest, and lots of different things like to live on the kelp, swim around the kelp, things like that. If people hunt all the sea otters for their fur, and you have a die-off of the sea otters, as a result, more urchins eating the kelp, less kelp forest, and less of all the things that depend on the kelp forest. Dominant species, in contrast to our keystones, they have a big influence because there's a bunch of them, either in terms of number or in terms of total size of stuff, or maybe both. Dominant species, that tends to be less diverse because to be dominant, one thing's dominating and the rest of the species might be present, not as many. So this may be a natural or artificial situation. For example, somebody keeping lots of cows, more than really the land supports so well, on an area where you have lots of cows, they eat up all the plants they like. You'll have less plant diversity because the cows have eaten a bunch of things. And you see the effects there. Or, say, central North Carolina into neighboring states, extending on around into the Gulf Coast to some degree. The sand hills, areas of very sandy soil. Sand, well, it's mostly just quartz, not great mineral variety for the mineral nutrients. Also, sand, water drains through pretty quickly. So sand tends to be fairly dry. This means dry conditions. What does Smokey say? High fire danger today. Burns easily. So the number of plants that like growing in these relatively dry, sandy areas is limited. Longleaf pine is specialized for growing in those circumstances. And so in an area where fire happens reasonably frequently, you tend to have lots of longleaf pine, and not too much of other trees. Or we've got a photo here. Okay, we see lots of grass, fair number of humans, and in the background, lots of kudzu. Not a whole lot of biological diversity. Here's very simplified versions of our bottom-up and top-down process. Top-down, a change in our top predators, the carnivores, impacts the herbivores, which impacts the producers, which impacts the demand for the basic nutrients. In our bottom-up processes, the levels down at the nutrient affect our abundance of producers, which affects the things eating those, affecting the things eating those. Connections go both ways, so we can have things going in both directions. And of course, in reality, complex webs rather than a simple chain would be more typical, and correspondingly, we're likely to see interactions and influences in many directions. How do we measure the diversity of a community? We've talked about more diverse, less diverse, but just how do you measure? And it turns out it's complicated. There are many different ways that people have developed to try to measure this. There are two things that we're going to keep in mind. How many different species are there, the species richness, and then the relative importance, and the evenness. This is something reasonably familiar if we're talking about, say, diversity in people. Okay, diversity, well, we've got 100 people here, and it includes people from 10 different countries. Okay, that sounds relatively diverse, but we've got one person each from 9 countries and 91 from the other country. That's not quite so diverse as it sounds like in saying that we've got 10 countries represented in 100 people. So the evenness, if we had 10 people each from 10 countries, that would be a more thorough diversity than 10 countries, but it's only one each for 9 of those countries. So the species evenness is that pattern of, do we have lots of one kind and few of others, versus more similar numbers across the board. Richness, how many total different kinds we have. And there are different ways we can think about how even things are. The density, how many individuals. Dominance, how much mass. So for example, out here on the quad, we have more dandelions than oak trees. But if you were to gather up all the dandelions and see how much total mass was represented there, probably be less than just one of the oak trees. So the oak tree, there's more oak stuff out there than dandelion stuff, even though there are more dandelions than oaks. Frequency, how widespread are they? Again, the dandelions are scattered all over the grassy area. The oaks, not quite so spread out. So you've got variation in those. And all those things you might be asked about for evenness. That's part of why there are so many different ways of measuring how much weight you put on these different factors. There are several possible formulas.